Hi, everyone. Thanks for having us. It's our pleasure to be here. And the next topic we are going to talk about is best fit.
Wait. I think we have a typo here.
Oh, sorry. It's WorstFit. Unveiling hidden transformers in Windows ANSI. An orange and his split line. We are excited to share our new research with you.
OK, so let's start with one story. One fateful day, I hacked into a bank.
Of course, this is a made-up story.
And yeah, since we hacked into the bank, so we have the full access to their database. Yeah, it's a PostgreSQL running on Windows. And yeah, it stores all the account information.
Wow, that's amazing.
Yeah, that's really amazing. And the first thing I did was checking my own account information. And I was poor as hell. I only had $14.50.
You are so poor.
Yeah, I was so poor. So I just did what every evil hacker would do, which is make my balance to the moon. I changed my balance to the infinity sign, and yeah, it worked perfect.
Don't do this at home.
Yeah, don't try this at home. So yeah, I exactly put an infinity sign here, right? So, but when I check my account information again, why is it only 8? I exactly typed the infinity sign there, right? Do you see that? But why is it 8 now?
You are more poor.
Yeah, I'm more poor. I'm even poorer than before. So this really pissed me off, and the IT guy found me. He just kicked me out. So after all of this, we tried really hard to know what just happened that time. And so this is how our research topic came to be. We will show you how did we turn this weird behavior into several bugs in this session.
Before we dive into the topic, let's introduce ourselves first. Hi, I'm Orange.
And hi, I'm Spillane.
We are both from DevCore research team. Our mission is to push the boundaries of security through offensive thinking. We always report our findings directly to the vendors to make the world safe. This research is also part of today. So let's get started.
OK, before we really talk about the vulnerability itself, we need to know this. Well, I think we can see Unicode in a lot of places. And in Windows, we have the file name, the file content, the environment variable, even the Windows registry. We can put environment variable. We can put Unicode string there. And just think about how does it store? Yep. So actually, Windows supports several ways to represent a character. Here we can see the evolution of encoding in Microsoft Windows. Well, at the beginning, it was so simple. We just need a single byte to store everything. And then we have Unicode. So at the beginning, they use UCS2 to do the Unicode encoding. And soon after, it's deprecated and upgraded to UTF-16. And this is the way Windows to store those internal informations. And yep, actually now we have UTF-8, but it's still in the beta phase. So in most of the language, the checked box is not checked yet. Well, so like in English, in Chinese, in most of European language, well, you cannot use the UTF-8 feature by default. But anyway, now we know all of this information are stored in the Unicode, which is actually a wide character format. And like the console input, file name, command line, Windows registry, environment variable are all stored in this wide character format. But you might say, wait, so I write my C program every day, and I always write it this way. I use the character, a single byte character, to retrieve those environment variables. But now you say it's stored in a wide character format. It doesn't make sense. And how about this? I read the Microsoft official document, and this get env function we can use this function to retrieve the environment variable within the single byte character format. But now you say it's in white character format. Well, it doesn't sound right. But yeah, it's all kind of not really Windows stuff. Let's get back to the real Windows stuff. So let's take a look at the Windows API. So actually, we have two different ways to retrieve the environment variable, which is one is get environment variable A, and another one is get environment variable W. And for the A one, it's actually ANSI format, and for the W one, it's actually white character format, and you will get the data in the Unicode format. Well, but now you might have one question. Well, so how can one data be in two totally different formats? One is ANSI, one is white character. How does it work? Okay, now we are going to show you one simple example to let you know how this works. Let's assume we have this environment variable, which is hello, HELLO. And we retrieve it with the white character format. It's white character originally, so white character in, white character out. Nothing changed, everything goes fine. Yeah, makes sense. But how about this? We use the ANSI API to retrieve the white character data. And now it will invoke a function internally, which is this long function name function. But here, everything still goes fine because HELLO are all in the ASCII range, so nothing need to change, just make it to the Unicode. Make the Unicode to the ANSI string. But how about we have this string, which is the square root of pi to the 7th power is less or equal than infinity. Yeah, this weird string, but anyway. And as you can see, they are all in the, they are not in the ASCII range, they are all Unicode character. They all have 2 bytes. So after ANSI, what's going on? Well, you can now guess a little bit, but I guess you cannot guess the right answer. Let's just show you. So this square root will become V, this pi will become P, this smaller 7 will become the bigger 7. And this less or equal than will become equal, okay? And the infinity sign will renew the answer, which is 8. Okay, how does it work? It totally doesn't make sense, right? So actually, this is really best fit. Yeah, now you can guess the formula or the pattern now. So, but let's tell you, what exactly is the best fit behavior? So first, the best fit mapping happens when the Unicode string is converted into an ANSI string. Yeah, so that's what just happened. And there's no specific pattern or formula, so Microsoft just want to make them look alike. Yep. So let's think if the infinite sign look like 8, okay, fine. But and there's another thing, which is different code pages maps differently. For example, for this U0085, which is a yen sign in the Unicode, in Japanese, it's going to be a backslash. In the Eastern European language, it's going to be a capital Y. And for all the other code pages, it's going to be still a yen sign. So because of this reason, the WorstFit vulnerability highly depends on the language configuration. Okay, now we already knew the basic concept of the best fit. Let's have Orange to introduce the first ever WorstFit vulnerability we found.
Okay, thanks to Spreadline. And although we told you that we hacked a bank in the beginning, in fact, the real story began from this CVE, a remote code execution on PHP CGI. As described, this is a bypass of an old vulnerability. The bug is quite simple. The design of PHP CGI is prone to argument injection. So in the good old days, you can simply inject the arguments through the query string to leak source code or even get code execution. It was really simple but dangerous. So PHP patched it quickly. Their fix was also easy, just to ensure there is no leading dash in the query string. The patch worked well, and no one broke it for the past 12 years. However, I felt that this blacklist looks weak. So I wrote faster and find why the ASCII 0xAD can bypass the patch. As investigating more, we find that the 0xAD is mapped to a dash, which led to the bypass. And we soon learned that this is best fit. This feature is super cool and motivated Spritline and me to take a deep look. As we delve deeper, we realize that the bug is just the tip of the iceberg. There are even more attacks on this feature. So that's how this research was born. Here are the attacks we have so far. Due to the time constraints, we will only cover 3 of them today. So let's begin with today's first attack, the WorstFit on the file name. This is a screenshot from one of my favorite hacker movies. The hero hacks into someone's personal computer to figure out who is the spy. Do you find anything special on this? Yes, white is the destination folder followed by a strange symbol. As Spritline mentioned earlier, the symbol is called the yen sign. And because this is a Japanese movie, all the backslashes in their computers are displayed as the yen sign. It might sound a bit strange, but don't worry. It's just for display. And the actual ASCII code is still 0x5c, the same as the backslash. But why did Microsoft decide to map the yen sign to a backslash? This can be traced back to several historical reasons. Back to 1996, the ISO attempted to create a standard that can cover as many languages as possible. So it opened several positions for countries to define their own characters. And one of the positions is 0x5c. Since the yen sign is used more frequently than the backslash in Japan, so the Japanese variant of the standard places the yen sign at position 0x5c. However, shortly, ISO introduced a new standard, which known as the Latin one. It's an 8-bit char set and includes a dedicated position for the yen sign. Since they look alike, so Microsoft said, OK, let's map them together. So that's why the yen sign is mapped to the backslash on Windows. And once we learned that, a straightforward idea quickly popped up. Can we use the yen sign as the file name? We tried to create one to verify that. We put it on the desktop and used the built-in function in Python to list the content of a desktop. Originally, Windows held the file name with the white character internally. However, the API required a single char array, so the best fit applied. Without any surprise, the folder with the yen sign will become the backslash. This allows us to perform path traversal to browse wherever we want. OK, we now understand the root cause. Let's exploit some real-world applications. Let's target the Cuckoo Sandbox. I'm not sure if you heard of this before. It's famous because it's a famous malware analysis platform. It's well known because it's the only open source solution. Since Cuckoo has reached its end of life, it keeps using a vulnerable Python version so that we can exploit it. The Cuckoo consists of 2 parts. the Sandbox host, and the virtual machine cluster to isolate the environment. The host on the left can inspect the virtual machine to collect the log, traffic, and dropped file. Since we can upload our malware, we can write a simple program to create a file using the white character API and put the ANSI in the file name. We can then correct the dropped files on the web interface. As mentioned, Cuckoo used an old Python which is vulnerable to WorstFit. So once we click the button, we can download whatever we want on the Sandbox host. We can then collect sensitive information for further attacks, such as bypass the authentication to convert this arbitrary file reading to RCE. Let's check the demo. So in the top window, you can see the Cuckoo, and we are running the Sandbox host on the left side. And the right side is the virtual machine that is waiting for our files to analyze. So we run our exploit to upload the payload, and after some magic, we pop the calculate successfully. Yes. OK, this is cool, but you might be thinking that this is Blackhat Europe. Why the speaker keep talking about the Asian code page? Actually, in the most code pages, the full-width reversed solidus is also mapped to the backslash, leading to the path traversal again. So do I really need to worry about that? Well, if you are using any of the following language, such as English, Spanish, French, Dutch, and more, they are all vulnerable to WorstFit. Or you can check this map. If your country is marked in red, you are likely affected by this attack. To be helpful, here is a tip for mitigation. You can switch your language to traditional Chinese. That's safe from such an attack. OK, let's hand back to Spritline for the next section.
OK, now we finish the past part, and now we start to talk about the WorstFit on command line. Yeah, actually, we mentioned about that earlier, which is for the PHP CGI case. But actually, we can do more with command line. And first, for this case, we have this. On an English configured Windows operating system, we have this Python script, which we use the subprocess to run the wget executable. And only a small little part of the argument is controllable. What could we go wrong here? Well, maybe if you are not familiar with Python, you might just say, OK, I can just use the command generation here. It's such easy stuff. Of course not, otherwise I will not be here, right? So we can refer to the document for this subprocess module. It just says you can safely pass those arguments into a child process. So nope, of course, and it's just remain the normal part of the argument. Yeah, and of course, this won't work. You cannot just inject an argument here. But how about this? Well, you might think, oh, wait, what's the difference? But don't care about that. I just pop a calculator out, such an easy stuff. What? Why? OK, let's have this challenge. I think most of you cannot find a difference. I mean, even Microsoft cannot find a difference. So on the left side is our exploit, and on the right side is totally safe from this kind of attack. So what's the difference exactly? Well, on the left side is the full-width quotation mark, and on the right side is the normal double quote. Well, but why? What's the reason make it vulnerable? Well, let's go back to this simple stuff, which is this command line. And how is it parsed? So let's start with Unix-like system, because I think most of you are more familiar with Unix-like system, and it's totally different from the Windows. And for Unix-like system, we have this command line. And first, it will be parsed by your shell, and it will separate it to several arguments. Now, it will invoke a system call, which is like this execute. And now, notice that we already have this separated arguments. And finally, the new process spawned is like a wget with the separated argument. And yeah, how about this? On Windows, we have the same command line. And we will throw it to the Windows API, which is like create process. But here, the second argument is command line. It's not arguments. I mean, like this. So the full command line will pass into the Windows API. So it's not argument. And now the new process spawned. So now it's the executable's duty to parse the command line. Yeah, it's right after the process spawn. It's parsed by itself. Now we finally have the arguments. So let's go back to the subprocess case. We have this Python script, and in the argument, we have a full-width quotation mark layer. And yeah, so the Python will try to convert Python list into a command line string. And since there's no double quote and no backslash, so there's no need to escape anything. So just pass it to the Windows API. Yeah, we have the same command line here, and then we will pass it to the wget or the vulnerable case. But the wget uses the ANSI API to retrieve this command line, so which makes it vulnerable to the WorstFit attack. The WorstFit attack is like, okay, I'm best fit, so I'm an ANSI API, and what is the full-width double quote? I don't know, but the best fit just say the full-width double quote is actually a normal double quote. So the command line will become like this. Now, a single argument is separated into 3. Yep, this is how these attacks work. And actually, we found many of these kind of bugs in a lot of common applications. Like in Java, in OpenSSL, in Subversion, in Perl, it's almost everywhere. And we think there must be more in the wild. Here we have this tar, which is a Windows built-in command as a case study. And the victim today is LFinder, which is a file management web application writing in PHP. So it has a function which you can make an archive based on several files. And it executes a command for creating archive. Now, it executes command sounds dangerous, but all the arguments are escaped by this escape shell argument, which is a PHP built-in function for escaping arguments, and it's safe. So we have this command line, and all the arguments are escaped, but the tar.exe is vulnerable to WorstFit attack. So here we can check the demo. First, we check the language configuration on the server, which is an English code page. And now we go back to the web application. We create an arbitrary file and create an archive based on it. Now we can set the archive name to a WorstFit attack. Then we can inject arbitrary argument to it. Now we have a calculator pop up. Of course, LFinder definitely not the only victim. We are able to pop more calculator with this kind of bug. Here we just pick several applications as a demonstration. Well, here we go. So on the right side is the RStudio, and on the right side is the Tortoise Git. And one calculator pop-up, and another pop-up. Perfect.
Yes.
And what's worse is no programming language can stop this kind of attack. For example, Rust, Python, Node.js, Golang, PHP, even you use the correct function to execute the command, you cannot avoid this kind of attack. And yeah, all of these code pages are affected. So all of these code pages will convert this full-width quotation mark into a normal double quote. So the way to do the mitigation, yeah, you need to switch it to CJK language, which is Chinese, Japanese, and Korean. But wait. I think we forgot one thing. Did you remember we have this? For the yen sign in Japanese and won sign in Korean, we can use this to map it to the backslash, right? And what can a backslash do? Backslash can escape stuff. And what can it escape? Did you get it? Let's just show you one example. Let's assume we have this program.exe is vulnerable to WorstFit. And we put the argument here, which is full yen sign double quote bar. And we have a double quote here, so the Python will try to escape it. And now it will prepend a backslash for escape the double quote. OK, now it's still fine. But after it's thrown into the program, the backslash will try to, the yen sign will become a backslash. So now the backslash will be used as escape the following backslash. Now the argument is separated into two. So yeah, this is a real-world map to show you who are affected by argument splitting vulnerability. And the real way to do the mitigation, yeah, you need to switch it to Chinese. Yeah, that's amazing, right?
OK, wow, that's amazing. You can imagine how many web applications will become vulnerable again. However, that's not all. This attack has the potential to target applications other than web. And the next case is going to be wild. Oops. On Windows, what happens when you double-click a file? Like this text file. We all know it will use Notepad to open that. However, how does Windows know which program to use to open the file? Actually, Windows maintains the table internally. You can see there is a handler for .txt, which opens the notepad and forward the file name as the argument. We can also use process monitor to check that. The command line should look like this. And since we can control part of the file name, can we use the same technique earlier to inject the arguments? Of course, we discovered several Windows applications are vulnerable to that, and Excel is one of them. And if we rename this Excel file into the following name, replacing all the slash, backslash, and double quote with their Unicode version. Once we double-click the file, the WorstFit will transform these Unicode characters to their normal version, that leading to the argument injection. Here we inject two more arguments to do further exploitation. And let's check the demo. The victim tried to download a malicious file from the internet. You can see the file is really strange. And once he opened the file, Excel will send an NTLN, and we can use tricks like ABCD or shadow credential to pop the calculator. Yes, that's cool. And additionally, the protection, such as mark of the web or protected view, will not help you because the argument parsing is not in their scope. So basically, all English and European-based Excel are vulnerable. OK, let's hand back to Spritline for our final attack.
Yeah, that's cool. So our final attack is environment variable. So when we talk about environment variable, the first thing pop out in my mind is CGI program. Since the CGI program uses a lot of environment variable to transmit those data like query stream, path, or HTTP headers. So if the CGI is vulnerable to the WorstFit attack, then there must be something going to happen. So when the CGI uses the ANSI API to retrieve those environment variables, those data will be vulnerable to WorstFit attack. Well, let's have this example. We have a web server, and it blocks the access to admin. So an attacker can create this kind of request, which have a text like %E0DMIN. And yeah, it's not admin at all, so it will just decode it and get this data, which has a path info, which has an accented ADMIN. And now it will be passed to the CGI program, and the CGI program uses the ANSI API to retrieve the environment variable. So now, best fit applied. Now the path becomes the real admin path. Well, this is cool, but it's still kind of an imagined case. Can we find a real-world case? Yep. So here we have PHP CGI again. The PHP CGI uses ANSI API in a lot of space. So here we have this kind of path, and we need to know how to see parsed. And we have index.php/foo/bar, and it will be passed to the server. And the server will generate a bunch of environment variable. So next, it will pass this kind of environment variables to the PHP CGI program. And then it will generate the file name of PHP and the path info. Notice that we have those paths are parsed by the PHP CGI itself. So you might think about, can we use the / again to confuse the PHP CGI to make it get a wrong path? Well, unfortunately, it will not work because the web server usually will validate the URL path. For this kind of case, it's like a //. It's obviously an invalid path, and you will just get a bad request. So here we have the yen sign again. We have this yen sign to get a \. We can use this yen sign to make it a part of the file name. And yeah, it's just part of the file name, so it's definitely not invalid. And now, when the PHP CGI uses the ANSI API to retrieve the environment variable, it will become // again. And now it will get the PHP file and path info wrong. How can we utilize this kind of attack? On Apache server, we can use it to detect a file exists or not. And this kind of useless, but actually we can do more with this on IIS. On IIS, with the document root configured, it can become local file inclusion. And since it's a local file inclusion, so we can actually achieve remote code execution based on it sometimes. That's quite cool. So we look into some common CGI. For Perl CGI, most of the components are all affected. And for PHP CGI, for such things like request and get, and also several variables in the server, will also affect it. Yeah. So here we have this best fit mapping again. We can use this full-width reverse solidus to map it to the / and make it vulnerable to path traversal.
OK, thank you, Spritline. Now we had finished most of our main section today. Due to the time constraint, there are still 2 parts that we don't cover. Maybe it could become some of your future work, I guess. As aforementioned, our attacks affect so many popular applications. Some of them are fixed, some of them are not. But why do so many applications do it wrong? It's quite common to have a main function, and you put all the application logic inside that. This approach works well on the Unix system. However, if you port the same program to Windows for any reason, it will be vulnerable by default. Why? To elaborate, we try to build a simple Hello World program on Windows and put a binary in a disassembler like IDA-Pro. We then check the cross-reference for the main function. You will discover, wow, there are a lot of code running before your main function. What? We only write a simple hello world, but why is there so much code that is not yours? So, who put this code? It's Visual Studio, the best in-class tools for any developers. Actually, Visual Studio will embed a lot of code to your program automatically while compiling. This is part of the convention for process initialization. The convention also called the ANSI API to retrieve the command line, which is vulnerable to the WorstFit. So what is the better way to use the main function? The safer way is to use the wman, the white character version of man. So is everything good? Actually, this only protects you from the command line parsing issue. There are more functions could be potentially vulnerable. Even if you don't use any Windows API, you might still be at risk because the underlying C runtime still uses the ANSI API. So, to fix everything, you have to replace all functions with their white character version, which is painful. So who is responsible for that? Is it the issue with the compiler and runtime provided by Microsoft, or is it the developer's problem for not using the white character API? We try to report to Microsoft first. We try to highlight this problem, but as you can see, it's not easy. The cast on Excel was only accepted on our third attempt. And for the tar cast, Microsoft said the scope is not covered by their service. Since Microsoft didn't consider it an issue, we then report these cases to the upstream instead. And here are the responses we got. The author of curl said that curl is also a victim, not the responsible party. OK. Perl said that it seems more like a Microsoft bug. Good. Postgre also said that's not their problem. And the maintainer from Postgre even tagged Microsoft to ask if there was a better way to use the Windows API. And unsurprisingly, there's no response. So the problems are still there, but no one wants to take actions. The good news is that we are now collaborating with CERT and hope everything goes well. Here is a world map to summarize our attacks. The countries marked in red are hardest hit, and the yellow are probably affected, and the gray is saved from that. Since WorstFit is binary independent, we also create a website to check the vulnerable executables. So contributions are all welcome. OK, let's talk about the mitigation. Since this is a system-wide problem, the best mitigation for users is to switch your system language to UTF-8. And if you are a developer, please use the white character version of Windows API as much as possible. And that's our presentation. If you have any questions, here is our contact information. Thank you for being here today. Thanks.